All right, in this video, I'm going to continue to look at the section 7.1, confidence interval estimates. So last time we studied the how to estimate, how to find out confidence interval, okay, to estimate the population proportion. Okay, so confidence interval. Oh, by the way, so inference statistic. Yeah, so we're talking about actual inferential statistic. So inferential statistic means that we use sample data to or sample space to estimate uh, the population parameters. Okay, so the parameters means that population characteristic population. So such as the you can see that proportions or mean and variance, things like that. So it's hard to or it's impossible to um, figure out such those values parameters. So we use sample data to approximate the parameters. The second one is test hypothesis, or is called the claims about population parameters. So point estimate is nothing but the uh, the approximation. Okay, a single value real number used to approximate population parameters. So the last time we learned how to calculate confidence interval. The confidence interval is the means the range of value used to estimate the true value of population parameters. So um, there is so now let's see second yeah here. So the confidence interval, the left hand number is p hat minus e, and the right hand number going to be p hat plus e. Okay, so p hat is the sample proportion, and the e is marginal error. So the um, the formula marginal error is this, but we learn. I introduced how to find the confidence interval using calculator, right? So you can use using calculator, you can find out the confidence interval without applying the formula. Okay. So p hat sample the proportion going to be x over n. Here x is the number of the outcomes in the event. Okay. So and then n is the sample size. Okay. The q is going to be 1 minus p hat. Yes. Okay. So here um, the q hat is the com the what the uh the complement of p hat. Okay. So now the so So we assume that the samples data will be selected randomly. Okay, and then give me a second. Yeah, so here the critical z value here see the z. So that the z is called critical z value. So that z score on the borderline separating area of alpha over two. What's alpha? Alpha is the one minus confidence level. Okay, so confidence level is here, and then the alpha over 2, that's the area. Okay, so the alpha is the 1 minus confidence level, and half of the 1 minus confidence level that's represent the area under the standard normal. This is standard normal distribution. Okay, and then z sub alpha over 2, that's the z score. Okay, so the separating the unusual to user. So what that means, so why we have to use the standard normal distribution? Well, we okay, so because the this is related to center limit theorem. So we're gonna the random um, select the sample data, many the the several times. Okay, so for each sample, then we're gonna calculate the sample proportion. Okay, so now and then the the zero sample proportions gonna be what the mean of sample proportions, the approach the what sample population proportions, and then that's approximately standard normal distribution. So the UNet, that's what we have to use standard normal distribution. So now standard normal distribution is the special case of normal distribution. So normal distribution has the bell shape, and then the center is here. The center is mean, and then um, but standard normal distribution is, yeah, has the same the shape as normal distribution, but the center, the mean is 0, and then the standard deviation is 1. Okay. So now anyway, so now see now we're gonna, in this video we see we're going to study how to find the sample size required to estimate the population proportion. So in the previous video, we learned the how to find out the confidence interval for given sample confidence level and then sample size, right? So this is opposite. So to find out the sample size required to estimate population proportion, we need to use the formula. Okay, in mathematically, you see here, E is equal to Z over G times square root of P hat times Q hat over N. So now solve we're gonna solve that equation for N. Okay, and then we're gonna get this. So here, I see that. So using this one, we can find out. You see, for given critical Z value and then P hat, Q hat, over, and then E should be given. Okay, so we can find out N. So and then we can use this one if p hat is known. What if p hat is unknown? Sometimes the problem doesn't give us the information about p hat. Then we're gonna assume that p hat is zero point 0.5, so that q hat gonna be 0.5. So 0.5 times 0.5 and then 0.25. So you use this formula. And the other one is this. We gotta find out the z critical z value. Okay. So what that means? So normally the problem gives us the confidence level CL. Okay. So then using the confidence level, we gotta find out the z score. Okay, corresponding to the alpha over 2. Okay. So let's see example. Okay, how many adults should we survey to estimate the proportion who shop online with 95% confidence level to within 3% percentage point? All right, so we gotta find out. I mean, we definitely use the what the formula n is equal to z square, okay, times p hat and then q hat over and then e square. Okay, so but the problems doesn't give us the sample proportion, so we don't know p hat. So then we gonna apply the zero point 0.5 into p hat, so the q hat gonna be also 1 minus p hat, which is 0.5, right? Okay, so that's gonna be z square times 0.25 over e square. Okay, and then we know the E actually. The problem says that how many others should we survey to estimate the proportion who shop online within 95% confidence to within 3% points. So E must be 3%, which is 0.05. Okay, so now here the E is what? 0.03 because E is represent margin of errors. Okay, so key minus confidence interval. P hat minus E, comma, P hat plus E. Okay, so it means that so what it means that there is 95% chance that the population proportion uh, belong to that interval. Okay, that's the meaning of confidence interval with the confidence level here. Confidence level is a 95%, right? Okay, so it means that alpha going to be the critical value alpha going to be 1 minus 95, which is 0.05, right? Okay, so now then what? So in the standard normal distribution in the graph, okay, so the area on here and here, there's gonna be r power over 2, there's gonna be r power over 2. So we gotta find out what z score is. This is negative z over r power over 2, right? This is z sub r power over 2. We gotta find out z score, who's the area under the graph of the standard normal distribution from negative infinity to here is r power 2. Okay, so how can you find out? We're going to use inverse norm in the calculator. Okay, so see, let's find out the critical z value. Okay, but in here we that that is a z r power 2. Okay, so to find out z sub r power 2, we're gonna use inverse norm the intrinsic function in that calculator. So we go to the distribution. See the distribution right there. So we press second and then variable here. You can see inverse norm in number 3. Enter. And the area must be 0.025. Yes, right? Because r power 2 is 0.025, right? The mu 0, sigma 1, because we're talking about on the under the standard normal distribution. Then we're going to get the minus 1.96 approximately. So that's going to be a minus 1.96. That's going to be what? 1.96. So this is going to be what? 1.96 square times 0.25 divided by 0.03 square. Okay. So we just can figure out decimal expression of this one, that fraction, using calculator. So I got 1067.111. Okay, so then the number of the sample size must be integer, right? So we're gonna round up to the next whole number. So that's gonna be approximately 1068. Okay, so this is how to figure out the sample size required. Okay, so next one question is how many should we survey if the Census Bureau estimate that 66% of others shop online? So the margin of error, I mean, that's the sub question of the previous example, okay, with the same confidence level, which is the 95% alpha, 95%. So alpha must be 0.05, and then margin of error is a 0.03. Okay, so that means a z alpha over 2 going to be 1.96. Okay, so now, yeah, confidence 11. I'm sorry, this is not 95. This should be. I'm sorry, I was confused. So the in that example problems, they have changed the confidence level to um, was the 66%. Okay, so see. Yeah, in this problem, this confidence level is same as 95%. Okay, and then the so that alpha going to be 0.05. Okay, and then so that g alpha over 2 is going to be 1.96. Okay, and then the problem says that how many should we survey if the Census Bureau estimate that 66% of others to shop online. So 6% means the p hat, okay, sample proportion. Okay, so p hat gonna be 66%, which means that 0.66. Okay, then q hat gonna be what? 1 minus 0.66, which is a 0.34, right? Okay. So we're gonna use the then the formula n is equal to z squared. Here z is actually z sub alpha over 2, okay? The p hat and the q hat over e squared. Since the what? Now p hat, q hat are known. Right? P hat is known, so we don't have to put 0.5 into p hat and q hat. So we're gonna plug in this one and this one, those two numbers into p hat, q hat respectively. And then z alpha over 2 is square gonna be 1.96 square times 0.66 times 0.34. Okay, divided by e squared is a point. By the way, here in the problem, then the example, the problem says that what 3%, which is the 0.03, right? So 0.03 square. Okay, so then we're gonna calculate this number. So I got the 957.83 yeah 839. Okay, so approximately. So now we're gonna round up. So we got 958, right? 958. Okay. So now let's see next. Yeah. So next example, estimate the population, a proportion of NG students who have tattoo with 90% confidence to within 8 percentage point. Okay. So so 90 confidence level is given 90%, and then 8 percentage points. So that's the margin of error. Okay. And then the problem doesn't give us the p hat, so we assume that p hat is 0.5. Okay. So in this problem's confidence level is 9%. So it means that alpha is a 10%, which is 0.1, right? Okay. Then z alpha over 2 is going to be. So we're talking about this under the standard normal distribution. Here is area going to be alpha over 2, which is 0.05. Okay. Here's also 0.05. What does that mean? Okay, so what does that mean? That area. This is that area represent probability that the what probability that the population proportion is the in the within the sample and within the confidence interval really. Okay, so that's the meaning of this. Now here this is going to be minus z alpha over 2. This is z alpha over 2. Okay, so what you're going to do, we use the inverse norm, right? So we go to the distribution and then using inverse norm. Okay, so now area going to be 0.05, the mu 0, sigma 1, because this is standard normal distribution. So we got the negative 1.6448. So we got the negative 1.64. This is going to be negative 1.64. That's going to be 1.64. Okay, so this is going to be 1.64. Okay, so E is 8%, which is 0.08. Okay, so now N going to be what? The 1.64 square times 0.25, because P hat times Q hat going to be 0.25, assuming that P hat is 0.5, and the E square going to be 0.08 square. Okay, so we calculating this one using calculator. So I got 105.06. So rounding up, we're gonna get 106. Okay. So so we need the 106 sample size 106 to get the to estimate the proportion of English students who have tattoo with 9% confidence to within 8 percentage point. Okay. So now next one is this example right here. So when the scientist Gregor Mendel conducted his famous genetic experiments with peas, one sample of offspring consisted of 428 green peas and 152 yellow peas. So 595% confidence interval estimate the percentage of yellow pea. Okay, so let's do this. So now here, what? So we need to figure. So confidence level is here, right? 95%. So alpha must be 5%, which is 0.05. And then so that Z's critical value, Z sub alpha over 2 going to be 1.96, right? And then what's the p hat? The sample proportion. going to be what the problem. You see, look at the problems. Estimate of the percentage of yellow peas. Confidence interval estimate percentage. So let's figure out the sample proportion of yellow pea, which is 152 out of what? Let's see, 680, right? So sample size is going to be 580. Okay, so sample size 580, and then 152 peas are their colors yellow out of 580. So that's going to be p hat, right? So let's do this. So in this that example, confidence interval level is 95%, right? Okay, and then so RPA is 0.05, critical value is 1.96. Okay, so then p hat is gonna be x over n, right? So a sample size, which is 580, right? And then x is a number of the p's whose color is yellow, which is 152, right? Okay, that's a p hat. Okay, so now let's find out then constant interval using calculator. So we go to the let's see the step. Okay, we go to the test tab. Then you see the we see the one. You see number 5, one proportion z test. Okay, so we click it. Oh, I'm sorry. One proportion z interval. I'm sorry. We are talking about confidence interval, right? One proportion z interval. Click it, and then x is the 152, and then n is of 580, right? C level 95%. Keep in mind is you have to convert the percentage to the number. 95% means 0.95, right? So like this. But now you see that here, that number, you can see that the first that interval represent the confidence interval. Left number represent p hat minus e. Right number and number represent the p hat plus e. Okay, what's a p hat? Is this 0.262? Okay, and it's a number sample size. Okay, so now let's move to the next problem. All right, see next problems. Based on his theory of genetics, Mendel expected that 25% of the offspring peas would be yellow. So given that the percentage of offspring yellow peas for the sample is not 25%, so you said we saw that, right? P hat is a 0.262, which is approximately 26%, right? So it's not 25%. So do the result contradict the Mendel's theory? But when you look at the what the confidence interval, what we got is what is confidence interval CI was the point 6 to 8, right? 6 to 8, combine the point 29786, right? 86. So definitely this interval um, is contains a 25%, which is 0.25, right? 0.25 belong to that interval. So even though the sample, the sample and each the sample proportion of the offspring yellow pea is not uh, you know it's not 25%, but we can say that the what the his I mean the the his theory is can be the confident 95% confident that the 25% of offspring p will be yellow. Okay, based on that confidence intervals. Okay, so keep in mind this confidence interval, you need to correctly understand the meaning of confidence interval. Okay, so and the confidence level too. So please look at the lecture slide. Okay, so there is the correct interpretation of confidence interval and confidence level. But so what does that mean? That confidence interval? It means this: when you 95% with 95 confidence level, right? 95% confidence level, the confidence interval. This it means that what when you just select the 20 samples, okay, 20 samples here, and then the uh what and then you just calculate the sample uh 20 samples, okay, and then using those samples we calculate the confidence interval, okay, then we're going to get 20 confidence intervals, right? And then only one except for one confidence interval, it means that 19 confidence intervals do contain the true population proportion. That's the meaning of that's confidence interval with the confidence level 95%. So it means that the confidence interval limits that contain the true population proportion 95% of the times. Okay, so that's the meaning of confidence interval. Keep in mind this. Okay, so the now so let's see move to do the results contradict? No, it doesn't contradict. Okay, the example, you have been given the task of estimating the percentage of Southwest airline flight that arrive on time. How many flights must you survey in order to be 80% confident that your estimate is within 3% points of the true population percentage? Okay, so this is asking about the sample size, right? Required, right? So here's get the problem A. Question A. Assume that nothing is known about the percentage of on-time Southwest flight. So we assume that we don't know about the sample proportion. Okay. So then these problems, what the competence level is 80%, right? 80%, 80%. So which means the point 8, right? Okay. So then alpha gonna be a 1 minus CL, right? Which is the point 2, right? Okay. So then and then alpha of 2 gonna be 0.1, and then what z value, z sub alpha of 2 gonna be what? Using the inverse norm. So right here. So using the inverse norm, let's see. Gonna okay, and then we go to the distribution, right? So we see inverse norm right here. Okay. So area gonna be what? Alpha of 2 is 0.1, right? 0.1, mu 0, sigma 1. So we got the minus 1.28, right? It means that that's the minus the alpha over 2, right? So the positive z alpha over 2 going to be 1.28, right? So let me write in the sketch papers. Okay. So okay, so CL is n is what? Here n going to be the z square times p hat times q hat, okay, over e square, right? Okay. So the here E problem says that within 3 percentage points, so E must be a 0.03, right? So 0.03 square, and then Z must be 1.28 square, and then times 0.25, because the problem says that we assume that we don't know about the percentage of on-time Southwest flight. So it means that we don't know about the sample proportions. Okay, so now we just figure out the decimal expression of this fraction using calculator in the round up. Okay, let me skip that process. And the next problem is this: assume that for a recent year, 84% of Southwest flight were on time. Okay, so it means that sample proportion must be 84%, right? So this problem equation A, this is here n gonna be then 1.28 square times 84% is 0.84, right? Square, not square, sorry. The point 16. This is Q hat. Okay, this is P hat. Divided by E square. E is 0.03, right? Square. So now, and then C, would it be okay to just select the Southwest flight between New York and San Francisco for your sample? Yeah, so the answer is what? No. Keep in mind is always the sample must be selected randomly. Okay, so keep in mind is the in the confidence interval, the this the sample size doesn't affect the confidence interval. I mean the confidence of confidence interval. Um, but when you select the sample, when you gather the data sample data, the RAM you have to select all data randomly. Okay, this is really important. Okay, not just New York and San Francisco randomly. You have to select them randomly. Okay, so now that's all about the chapter 7.1. Okay, so next time we're gonna study how to find the confidence. I mean, estimate confidence interval of the population mean when sigma is unknown, and then okay, so and then how so similarly we're gonna figure out how to find out sample size required to estimate population mean.